This question belongs to the Indian National Physics Olympiad-2023. This examination was organized by Homi Bhabha Center of Science Education, Tata Institute of Fundamental Research, Mumbai in January 2023. And this was the first question of that paper, and this paper belongs to the concept of bouncing of the spherical steel ball. In this question, small spherical steel ball is thrown up such that it almost touches the ceiling and comes back without hitting. The ball hits the floor and thereafter it keeps bouncing, and sound detected by a app, wave editor. This, by the help of this app, the sound wave was detected, and it is seen that this is the screenshot of that app. It is seen that the app records a peak at first record at 10.260 second when the first time the ball hits the floor, and make reasonable assumptions when the ball hits the floor and calculate the height of the classroom. We have to determine the height of the classroom by the help of this given data. This is the time of first sound of first bouncing, which was recorded by the app. This is the time for second bouncing. This is for third. This is for fourth. These are the timing for the bouncing of the ball, which was recorded by the mobile app. So we know that, suppose this is floor and this is ceiling. This is the height of floor from ceiling, h0 we can consider, and when ball bounce we can consider this height is h1. This is first bouncing. In second bouncing it may be h2, and in third bouncing it may be h3, as the height of the bouncing should be continuously reduced. In each bounce the ball loses the same amount of energy as the shape of ball and floor are uniform. And if we consider that E0 amount of energy in starting and E1, E2, E3 are the energy remaining, E2 energy for this bounce, E3 energy for this bounce, and the ratio of every two bounce of the energy, it should be the equal to each other. So E0 upon E1, it should be equal to E1 upon E2 and E2 upon E3 and so on. So we can see that for this E0 upon E1, it should be H0 upon H1, as M into G remains same for every bounce. And similarly E1 upon E2 should be equal to H1 upon H2, and E2 upon E3, it should be H2 upon H3. If we take the ratio of height for first two bounce, then we can consider that it should be H0 upon H1 equal to H1 upon H2, and we can take H0 into H2 equal to H1 square, and H0 equal to H1 square upon H2. So if we determine we have to determine the value of H1 and H2 to solve this equation, and for determining H1 and H2 we can consider the time interval between first and second bounce. Suppose it is delta t1, and time interval for second and third bounce, it should be delta t2. So it should be H1 equal to 0 ut plus half gt square, half G delta T1 upon 2, as delta T1 is total time and we are taking time for one H1, this is height, and delta T1 is up and down, time for up and down. So we have to take delta T1 upon 2 square. Similarly, we can take H2 equal to 0 plus half G delta T2 upon 2 square. And we can put the value of H1 and H2 in this equation. So H0 becomes H1 square upon H2, or we can say G by 2 delta T1 square upon 4. This is H1 and this is H1 square upon H2 means G by 2 delta T2 upon 2 square. This is H1 square upon H2. And now it becomes G square delta T to the power 4 upon 2 into 4, 8 square 64 upon G delta T2 square upon 2 into 2, 4 into 2, 8. And now 1 G cancel out and 8, 64, it becomes 8. So G by 8 delta T1 to the power 4 upon delta T2 square. Now we have to determine the value of delta T1 and T2 by the help of this screenshot of the app. So first time is 10.26, second bounce time is detected 11.409. So time difference between these two is 11.409 minus 10.260, and it becomes 1.149 second. And if we determine delta T2, it should be 12.244 minus 11.409, and it becomes 0.835 second. This is delta 2. Now we put the value of delta T1 and delta T2 in this equation. So H0 becomes 10 into delta T1 is 1.149 square upon 8 into delta T2 is 0.835, and we will take it 9.8. And after solving it, the answer becomes 3.06 meter. So height of the classroom, it should be 3.06 meter. So dear students, this is the solution of this problem, and we will meet again with another second problem of the Indian National Physics Olympiad Info 2023.